Alright guys, so I found this website and we are going to explore it a little bit and learn a little bit more about circuits from yesterday. Alright, let's see. How many people? There's one. And it is me. Alright. Got it. Okay. So, it says that circuits need to be complete for them to work properly. This means that the wires must go in a full loop around the power source and back again. Circuits that are not complete will not work. So they said go in a loop. I said circle, circuit. Sounds the same, right? Circuits that are not complete will not work because the electricity cannot travel around them properly. None of these circuits are complete, so none of them will work. Can you see why? Ooh, that one's not. Ooh, that one's missing a wire. This one should have been on that side. Oh, look. It doesn't go in a complete loop. It's got to go in a complete loop. A power source can be either cells, which are called batteries, or mains. This is like your on the wall, the switches and the plugs. Remember that mains electricity is much more powerful than batteries and can be very, very dangerous. Do not mess around with electric mains. So the things on the wall, your switches, those kind of things can really hurt you. So don't mess with those. If you're using more than one cell in a circuit, remember that they need to be connected so that they are all facing the same direction in the circuit. The positive, bumpy end, and one cell should connect to the negative flat end of the next. So if you're attaching more than one battery, they have to be in line, where it's the bumpy end to the flat end, not bumpy to bumpy. That's wrong. All right. So some materials will allow electricity to travel through them, and we call these materials conductors. All right, we've talked about conductors. The piece of metal in the circuit allows electricity to travel through it so the bulb lights up. All right, so here's our metal, and it allows it to travel through. Other materials do not allow electricity to pass through them. So here they put plastic. That is an insulator. There's lots of different insulators. So we've got plastic, rubber, glass. I know rubber. Oh yeah, rubber's there. The plastic does not allow electricity to go through it, and so our bulb does not light up. So here's a picture I was trying to describe of wires to you yesterday. And some wires, they have a plastic coating on the outside. In fact, the wires that are in your house, in my classroom, in your classroom, they all have a coating to protect us. The copper, so this inside, is a conductor and carries the electricity. The plastic part is the insulator and stops it from traveling into other objects that touch it. So when we touch the wire, we're protected. Remember, insulators are protectors. Metals like steel, copper, iron, gold, and silver, they're all great conductors. Graphite, which is a type of carbon, also conducts electricity, but most conductors are metal. Graphite is what pencil lead is made out of, and that's a conductor also. So keep your pencils away from the plugs. A simple circuit with a cell and a bulb is not very useful because to turn the lamp on and off, you would have to remove your wires. So that's why people put switches on things. Switches are useful because they give you control over your circuit, like our light switches. Switches allow you to make or break a circuit. Okay, when the switch is in the on position, the circuit is complete. When the switch is in the off position, we say the circuit is broken. Switches come in all shapes and sizes, and they're different types. So here we have a push switch, something where you can just push a button, and then this one is more like a light switch that toggles back and forth. Switches are used in lots of things that control electricity. The buttons on things like calculators and keyboards, they're just switches. That's all they are. So look around your home and see if you can find anything with switches. So you can make a circuit more complicated by adding things. You can add extra light bulbs. You can add extra cells or batteries. If you want to add more bulbs, they are not going to be as bright unless you add more battery. And then if you add more battery, they're going to shine brighter. All right? So adding more cells in a line to a circuit makes the bulb glow brighter because there's just more electrical power. But if you add too many cells, then your bulb can burn out. Okay? It can be too much power for your bulb. You can also change a circuit by changing the length of the wire. So you can add wire here. Now, as the wire gets longer, the bulb's going to get dimmer because it's going to take longer to get that electricity to it. So if you want your bulb to be brighter, make your wires shorter. So there's lots of ways you can change circuits. It says it's important just to change one thing at a time, just to see kind of how you're affecting it as you're building it. And I really wish y'all were here because we could be building circuits together. But I found a website. I want you to try to get onto it and see if you can build some circuits. All right, so here was a little more information on circuits. They're really awesome. And so I hope y'all can get on the website and practice building some.